We just learned the three types of intermolecular forces: dipole-dipole, ion-dipole, dispersion force. Let us talk about the dipole-dipole force. The dipole-dipole force occurs between two substances that are polar. Here is a polar water molecule, and here is another polar water molecule. Okay? Because this hydrogen here is partially positive and this is partially negative, the red dots is the dipole-dipole force. Here's another example of a dipole-dipole force. You have HCl, and you know that Cl is more electronegative, so it will have a partial negative and the partial positive on the H. A partial negative on the Cl, a partial positive here. HCl has dipoles, two poles. This also has dipoles. So dipole-dipole, the positive and the negative will attract, causing an intermolecular force called the dipole-dipole force. I just wanted to show you this image because water is so special. As you can see, for every one water molecule, you can have multiple dipole-dipole force occurring. And this is one of the reasons why water has such a high surface tension, where it's so hard to break all those different dipole-dipole force. Okay. Also, this shows the difference between a covalent bond. So this line right here is 100 picometers, which is shorter than a dipole-dipole force of 180 picometers. So which do you think is stronger, the covalent bond or the dipole-dipole force? This covalent bond is a lot stronger because they're closer together. This dipole-dipole force is weaker. Therefore, when you boil water, you are breaking the intermolecular force apart, but you're not breaking the water molecule itself. It's still intact as a water molecule. Okay? So there is a very special type of dipole-dipole force called a hydrogen bond. Okay? It is a dipole-dipole force, and it happens when the H of an atom is the H atom in a molecule is bounded to a small, highly electronegative atom. Okay? So, for example, if H is bound to F, then this substance, this H can hydrogen bond with something else because F is very electronegative. If H is bonded to an O, then this H can hydrogen bond because O is very electronegative. Okay, and also with N. N attached to H, this H can hydrogen bond. Okay, so the elements which are so electronegative are F, O, or N. So as you can see here, F is the most electronegative. It's smaller, right? So the O and the N. And these are the top three for hydrogen bonding because they're the smallest and very electronegative. So let me show you an example of a hydrogen bond. I know that was a little bit hard to understand. So here we have ammonia. Ammonia is a trigonal pyramidal substance where the H's are pushed down because of the lone pair here. Okay. So ammonia is definitely polar. All right. That's one ammonia molecule. Now let's look at another ammonia molecule. Okay. So here we have nitrogen as very electronegative, which makes this partially negative and a partial positive here, partial negative here, and a partial positive here. Okay, because this is partially negative, the H can form a hydrogen bond with the N. Okay, the reason this happens is because the nitrogen here is so electronegative that it pulls electrons away from the H. As a result, the H becomes very positive and very small. So here are the two ideas: very positive, very small. which means the nucleus is exposed. The nucleus of the hydrogen is exposed, which is actually a positive charge. Since the nucleus is exposed, it is able to get really close to something that is negative. This negative can be oxygen, it could be nitrogen, it could be fluorine. Okay? Remember, the closer two charges are to each other, according to Coulomb's law, the stronger the force. This is why hydrogen bonds are so strong. Okay? Again, hydrogen bonds are especially strong. Hydrogen bonds are a strong type of dipole-dipole, strong type of dipole-dipole force, and the reason it's so strong is because the H is bonded to a very electronegative atom, to something that is so negative, electronegative, that it pulls electrons away from the H. From the H, causing the H to be very, very attractive, and because of all these reasons. Okay? So let me show you another example of a hydrogen bond. When H is attached to F in HF, this fluorine is so electronegative that it pulls electrons this way, making H very, very positive and attractive. So it can bond with something else. So it could be another HF or it could be another substance. It doesn't matter. Okay, it could be, this H can hydrogen bond with a water, for example. That is still hydrogen bonding. Okay, so let me just show you that hydrogen bonding is the ... force in between, but this bond right here is not a hydrogen bond. It is not an intermolecular force. It is a covalent bond. So don't get confused about that. Okay, I'm going to show you another hydrogen bonding is when H is attached to a very electronegative O. Okay, this H, this O pulls electron density, making H very positive, causing the H to hydrogen bond with another water molecule, causing water's boiling point to be so strong because this force is very, very strong. And as you can see here, it doesn't only happen once, it happens many times within each water molecule. So again, hydrogen bond is a special type of dipole-dipole force, and it's especially strong. And it happens when the H is attached to F, O, or N. That H can hydrogen bond with something else.